Welcome to third in the series of videos on area and perimeter of plane figures. In this video we're going to do the following listed problems for triangles to find the area. So first one is let's dive straight into it. So the first one is calculate the area of equilateral triangle whose height is 20 centimeters. So all these problems require you to use some ideas on properties of triangles and stuff like that. So you know that equilateral triangle means all sides are equal, and given that your height is 20, so you also know that in an equilateral triangle the perpendicular is actually the median. So one side would be a by 2 and the other side would be a by 2. Since you know the properties of this equilateral triangle, now with these properties in hand, you can easily go about finding what you need. So let's take triangle, in triangle ADC, we know that AC squared equal to AD squared plus DC squared. And AC squared is nothing but A squared equal to AD squared is 20 given, plus your DC squared is A by 2 the whole square. So what that gives us is, well, it is also a good idea to write down the values, right? You can say, hey, AC equal to A, AD equal to 20, and DC is equal to A by 2. So you can write this and this together just to make sure that it's there in your head, and then you can find out the value of A squared minus A squared by 4 is 20 square, and your A squared, 3A squared by 4 would be 400, or your A squared equal to 1600 divided by 3. Now your area, once you know this, then you know that the area is nothing but area of equilateral triangle. You can either do half of base into height, or you can also write it as root 3 by 4 A squared. We know that the area of equilateral triangle is root 3 by 4 A squared. So we can say, hey, it's root 3 by 4 into 1600 divided by 3, and that would be this would be cancelled, and this is 400. So it's 400 into 1.73. It helps to remember these numbers, at least for root 3, root 2, etc., divided by 3, and that amounts to 230.9 centimeter square, right? Alternatively, you can instead of using this root 3 by 4 A squared, you can substitute for this, and you can say that, hey, your area is half into base is A. So in this particular case, it is square root of 1600 divided by 3 into height we know is 20. So that will be square root of 1600 is 400, and divided by into 20 here, into 20, right? So square root of 1600 would be 40, and here this 20 and this 20 and 2 will get cancelled. So you have 40 into 10 divided by square root of 3, that is equal to 400 into root 3 divided by root 3 into root 3, and you get the same answer, right? You get 400 root 3 by 3, which is same as this. So So you have to write your answers in decimals. Now let's do the next problem, which is the area of isosceles triangle whose equal sides are 5 and base is 6. So the second one is area of isosceles triangle whose equal sides are 5 and your base is 6. So this is 6 centimeters and this is 5 centimeter and 5 centimeter. Now you can do this in two ways. You can either substitute for your isosceles triangle the equation, and you can try to find that out. You know that for isosceles triangle, area is given by 1 by 4 b, which is the non-equal side, into square root of 4a squared minus b squared. So that will be equal to 6 by 4 into square root of 4. A is equal sides, so 4 into 5 squared minus 6 squared. That will be 6 by 4 into square root of 4 into 5 squared would be 100 minus 36. That will be 6 by 4 into square root of 64, or it will be 6 into 8 divided by 4, or 12 centimeters square. So you can apply this formula, but let's assume that you don't remember this formula. So if you don't remember this formula, you can always come from your first principle, which is what I would always recommend, and you can draw the perpendicular, and you know that that's going to bisect this side to 3 centimeters. So this height h would be equal to square root of 5 squared, because in this triangle A, B, C, D, so this is from triangle ADC, you know that your h squared would be equal h squared plus 3 squared, right? H squared plus 3 squared. Using Pythagoras theorem, you can say, hey, h squared plus 3 squared equal to, this side is 5 centimeters, right? So this side is 5 centimeters. So equal to 5 squared. And that will give you h as 25 minus 9 h squared, or in your h equal to square root of 16 equal to 4 centimeters. So now once you know what your h is, this, if h is 4 centimeters, then your area would be equal to half of base into height, that is equal to half of 6 centimeters into 4 centimeters, and that will again be 12 centimeters square. So you can either do the method 2, which is coming from the first principle, or you could use the method 1, which is your direct formulae. So let's look at the third problem now. So you've been asked to find the area of ABDC, which is basically this area. So you've been asked to find this area, and we know that this is 10 and this is 10 and this is also 10. So it looks like an equilateral triangle, and you need to find the area of the shaded part, right? So let's do this one. In this problem, the area of the shaded portion, your area of shaded portion, would be equal to area of triangle ABC minus area of triangle DBC. Now we know that, you know, area of triangle ABC, it's an equilateral triangle, so this is root 3 by 2 into 10 squared, minus, we know the triangle DBC is a right angle triangle, so this would be half base, which is, this is your base, into the height, which is this quantity. So you can say this is equal to half of base is 8 centimeters into height is DC. So we don't know what DC is. That you can find using Pythagoras theorem, right? You're in triangle BDC, 10 squared would be equal to 8 squared plus DC square, or your DC square is 36, or DC equal to 6. So you can substitute that here as root 3 by 2 into 100 minus this is 4 into 6, and this would be root 3 is 1.732. I'm sorry, this is 4, this is not 2. So 1.732 by 4 into 100 minus 24. And if you calculate this, you will get the answer as 19.3 centimeters square. So that's your answer. So I urge you to try out all this problem once yourself before you proceed into doing your worksheet and exercises, and make sure that you have these concepts grappled in your head. It's quite easy. I hope you'll have fun. See you until the next video. Bye.